Questions number 6 and 7. For each of the following sequences, determine whether it is arithmetic, geometric, or neither, and write a recursive definition. So the first thing you'll notice that I did on these questions is that I rewrote the tables. And why did I rewrite the tables? Well, you can see in number 6, I skip from term 0 to term 2, and then skip from term 2 to term 6. So to figure out what type of sequence I have, I need to know what the in-between terms are. And I did the same thing in number 7. In number 7, notice I jump right from term 0 to term 4. So let's go back to number 6 and let's see if we can figure out the middle, those in-between terms that are missing that will allow us to determine the type of sequence that it is. So if I look, I go from term 0 to term 2. I go from 16 to 9. So that's going down by 7, right? 16 to 9 is going down by 7. So what is half of 7? Well, half of 7, 7 divided by 2 is 3.5. So if I subtract 3.5, I should be able to find the middle term. So 16 minus 3.5. And if you can't do it in your head, that's okay. Use a calculator, use the one on your phone, use Desmos, use the one on your computer, whatever you're comfortable with. So 16 minus 3.5 is 12.5. The question is 12.5 minus 3.5 equal to 9? And it is. And now let's keep following that pattern and see if I end up with a term 6 of -5. So 9 minus 3.5. Again, I'm just using the one on my phone. This is going to be 5.5. 5.5 minus 3.5 is 2. 2 minus 3.5 is -1.5. All right. If I'm correct, then -1.5 minus 3.5 should be -5. And it is. So it's pretty clear that my pattern is to subtract 3.5 each time. That's an arithmetic sequence. So number 6 is an arithmetic sequence because I'm subtracting 3.5 each time. So the recursive definition, so what is my f of 0? What is my starting term? My starting term is 16. So f of 0 equals 16. And then to get a new term, f of n, I'm going to take the previous term, f of n minus 1, and what am I going to do? I'm going to subtract 3.5. So f of 0 equals 16, and f of n equals f of n minus 1 minus 3.5. So that right here is my recursive for number 6. Number 7 looks interesting. It looks like it could be a geometric sequence, but let's double check here. If I go from 48 to 96 in term 4 to term 5, going from 48 to 96, I believe that is multiplying by 2, but I'm going to double check with a calculator just in case. Is 48 times 2 equal to 96? And it is. So I'm going to see if I start at 3 and I multiply by 2 each time, is that going to work? Okay. So let's see. 3 times 2 is going to be 6. 6 times 2 is going to be 12. 12 times 2 is going to be 24. Is 24 times 2 equal to 48? Yes, it is. And of course, we already knew that 48 times 2 is equal to 96. So it would appear that my pattern here is to double, to multiply by 2. So this is definitely a geometric sequence. So my recursive, f of 0 is going to be equal to, what's my starting term? 3. And then f of n is going to be equal to f of n minus 1. And what is my pattern? Times 2. So f of 0 equals 3, and f of n equals f of n minus 1 times 2.